Hello everyone, this is me, your electrical Guruji, and in this power electronics series, today we are going to see buck boost converter. So without any delay, let's start with today's topic, that is buck boost converter. What are these buck boost converter? So now, as the name indicates, buck boost converter is a combination of buck and boost converter where we can increase and decrease the output voltage. Let's see the definition. A buck boost converter is a switch mode DC to DC converter in which the output voltage can be transformed to a level less than or greater than the input voltage. So as it is the combination of buck and boost, we can step up or step down the output voltage. Now let's see what are the applications of this buck boost converter. It has wide range of applications. It can use in self-regulating power supplies. It can use in consumer electronics. It is used for battery power system. Then adaptive control applications. It can be used in power amplifier applications, solar energy systems and battery management system. And the most important is hybrid vehicles. Now let's see what is the working. As we can see here, the circuit is the combination of buck converter as well as boost converter. Now here the switch, instead of connected in parallel just like boost converter, the switch is connected in series with the input supply and the inductor is connected in parallel. Now if you can see, the diode is connected in reverse direction, that of our buck and boost converter. There is an important role played by this diode which we are going to study during the operations. The capacitor is used for maintaining the power supply during the off period. Now this is the waveform, and we'll see the working during both the modes, when the switch is on and when the switch is off. So let's start with the on state. When switch is on, during this period this inductor gets charged due to the input voltage, and as the diode is connected in reverse bias, this current cannot flow to the load. So during this period the capacitor provides the power supply to the load, and the polarities are shown here. Due to this, the current is in upward direction, which again provides polarities like this to the load. So here the current is in reverse direction. Now let's see what happens during off period. During off state, as the switch gets open, the inductor is already charged in this downward direction. So the current starts to discharge on the load as well as to capacitor. So due to this, the discharging curve is shown over here, and due to this again the capacitor gets charged with the respective polarities, and again the current is in upward direction. The direction of current is same that of our previous mode, and which generates the polarities like this. So this is the basic working of the buck boost converter. Now we'll try to find the equations for current as well as voltage. So let's analyze on state. During on state, switch is on, which due to which the inductor gets charged. So due to which the input voltage Vs is equal to inductor voltage. Again we know that what is inductor voltage, it is L di by dt, again which can be simplified like delta I by T on. So due to which we can find out delta I. Delta is Vs into T on divided by L. Again we know that T on is equal to dt, because duty ratio is the ratio of T on by T. So that's why T on becomes dt. Okay, it's similar to boost converter. Now we'll analyze the parameters during the off state. So when the switch gets off, in that case inductor voltage is going to fade the output. So that's why output voltage will be equal to inductor voltage. That's why we can directly say that V output is equal to inductor voltage. Now again if we simplify, VL is equal to L di by dt. Again instead of di we are going to use delta I, and the period is considered as T off period. So again we can find out delta I is equal to V output into T off divided by L. Again we can find the equation with respect to the duty ratio, and it is comes out to be delta I is equal to V output 1 minus D into T, that is total time period, divided by inductor L. We'll see the voltage equation. In order to find voltage equation, we can equate both the equations. Both the right hand side and left hand side are equal to each other. So L get cancelled and T get cancelled, and we get V output is equal to Vs del D duty ratio divided by 1 minus duty ratio, and this is the output voltage equation. So now let's summarize what we have studied in this video. So we have seen buck boost converter, so it can step up or step down the voltage. We have seen the application as it has very wide range of applications. Then we have seen output voltage equation, that is Vs into duty ratio divided by 1 minus duty ratio, and we have studied the current equation during both the period when switch is on and when switch is off. So thank you very much for watching this video. Hope you like it. If you like the video, please like the video and subscribe the channel. Stay home, stay safe, and fight corona by staying in your homes. Thank you.